So, my friends, today we are going to go over the number line and sign numbers, aka integers. I always have to do the bubble letters beforehand, because that way they could see it when you go to the little YouTube channel. So, before we get into the rules, before we get into the process of integers, adding, subtracting, multiplying, dividing, sign numbers, which majority of you pretty much remember or already know, but for some of you it's brand new. Before we get to that, we got to learn a little something. The little something known as the number line. So the number line, it's important because it visibly shows the numbers. All of the positive and the thing that we're working on from this point forward, all of the negatives. So, I'm almost for certain that from this point forward, with the more advanced algebra that we do, with everything that we get into, I'm almost for certain that the negatives are going to be what trips you up. You could do all of the work that's necessary to do in math when it comes down to solving an equation, solving an expression, simplifying, da-da-da. But the moment you do all the math and you get down to the last step, which is to bring down a negative or something, or do a negative operation, that's when you'll get the wrong answer, right at the end. So it's important to be on top of your negatives and not let it trip you up. Because, again, I'm almost for certain that it will, at least with one problem. And Steven, you get crazy when you miss just one problem. Am I right? So, you don't want that. But the number line kind of helps you when it comes down to certain operations. So, if we look at our very first operation, such as this one right here, 1 plus negative 4. Actually, you know what? Scratch that. I want to do 1 minus 4. 1 minus 4. So I know in math, before getting to algebra, they tell you when you can't subtract something, you carry over and bar. You do that whole little process that we do. When you have a problem like this, we get into the infamous negative part of the number line. And it's important to not ever put this in the calculator or in your mind, say 4 minus 1, right? It's important to note that it's 1 minus 4. Neil, you can't do 1 minus 4, you only get 0. Is the answer 0? No, it's a negative. Look at the number line. You could visibly see it. Let's say you started here at 1. Let's say 1 representing the amount of money you have in your bank account. $1. Then you go off and you use that credit card of yours, which is automatically linked up to your bank account. And you go off and you buy a hamburger that costs $4, right? And it goes through. It's the reason why. There's a reason why. It's because bank accounts can actually get into the negatives. If any of that's happened to you, I apologize. I probably know the feeling of getting into the negatives, right? But it could happen. You have your $1 in your account. Out of nowhere, it gets withdrawn. $4. All right. 1, 2, 3, 4. How much do you have in your bank account now?
Minus 3.
Negative 3. That's the number line. Visibly, you could see that it can be done because there are numbers below 0. There are negatives. 1 minus 4 is equals negative 3. And it's important to note negative, when you have a minus operation, yes, you go that way. Let's pretend we have, actually, yeah, -4 plus 6. Where do I start off at? You start off at -4, and what do? Do you go this way or that way? Well, it's an addition problem, so that's why I have to go this way. How much do I go by? 6. 1, 2, 3, 4, 5, 6. What are you left over with?
2.
-4 plus 6 equals 2. The number line, it helps you visibly see it, and it's always important to keep that in mind. But the number line is the last thing I want you to ever do for bigger numbers. Let's say we're given a problem like this. (15) plus a -25. The last thing you must ever do is on a scratch piece of paper for a problem like this is draw yourself a number line. Start out at 0, do your ticks all the way up till you get to 30 on each end, and then put it at the 15, then you add, but then you go the opposite way, -25. It's too much work, too confusing, and too much time wasting, my friends. That is why that worksheet that I gave you, that little cheat sheet I should say, is important to remember. Is because there are 4 rules that you have to memorize. And yes, you have to memorize. For problems like these, in which you aren't going to be allowed to use a calculator, obviously. Again, for those of you taking your GED, you might really want to hear this, because on the first 5 questions, you are not allowed to use the calculator, which means, yes, they're going to throw at you ratio and proportions, fractions, decimals, and without a doubt, 100% certainty, they will give you negatives. Negative operations that are a bit more complicated than just this. So you got to learn how to do it by hand. And these rules are important. Let's look at the rules. I think I have it here. There's our rule. If we look at the first section, adding integers, we're looking at it right here. Adding integers, as in adding numbers with different signs, positive, negatives. There's a little rule that goes, same sign, if they have the same sign, but it's an addition problem, you add and keep the same sign. Well, how does that work? Well, let's look at it like this, my friends. 15 plus 3. Well, this one's pretty straightforward, but hey, we have to start off with the simplest ones anyways. The rule says if you are adding numbers and they happen to have the same sign, you add and keep the sign, which means here it's an addition problem, obviously, because of the plus. Do your numbers have the same sign? Yes, they're both positive. So what do? You add them up. 15 plus 3 is obviously 18. And then you keep the same sign, which in this case is a positive. We do this daily. We never really use the little rules because this is natural to us. But looking at it like that could help us with problems like these. Let me switch it up. 12 plus. So, is this an addition problem? Yes, because of the operation. The middle sign, the middle symbol, will tell you whether you're going to add, subtract, multiply, or divide. In this case, it's an addition symbol, so we're adding. Because it's an adding operation, what you must do is, if you listen to the rule, it tells us if you are going to add integers, check if they have the same sign or different sign, which I haven't done an example yet, but do these numbers have the same sign? Yes, which means you do exactly what the rule tells us. The rule tells us if they have the same sign, add and keep the sign, which means what's 12 plus 3? What is the sign that they both have? It's a negative. The sign to the left, it's a negative. This one negative. They both have matching signs, which means you keep the same sign, which your answer, which was 15, keeps the same sign, negative 15. Again, that's only if you are doing addition and if your numbers happen to have the same sign. So, what happens, my friends, when they have different signs, though? It says subtract and keep the sign of the bigger number. Did anybody write down the original problem that I had right before I put this picture up?
15 plus minus 25 parentheses.
15 plus negative 25? Okay. So, is this an addition problem? Yes, it is. It's adding integers, which means you should be looking at this section right here. So it's an addition problem. Now ask yourself, do they have the same signs or different signs?
Different.
Different, which means that is when you use that rule that we just said, which was find the difference between the numbers and then keep the sign of the bigger number. What does that mean? That means exactly what it means. What is the difference between 25 and 15? The difference is 10. If you do 25 minus 10 or 15, you get 10. So, you're always looking for the difference. So, all I care for is the number, the difference. 10. Now ask yourself, what is the sign of the bigger number?
Negative.
Negative. The 25 is obviously bigger than 15. What is its sign? Negative, which is why it becomes a negative 10. These tricks, these rules, memorize those rules by the way, is what helps us when we are left with no calculator and are given large numbers. Negative 36 plus 16. So, break it down. Is this, yeah, this is an adding problem. It's adding integers here, right? So, if you know you're adding here because of that sign, you must ask yourself, are the numbers, do they have the same sign or do they have different signs? Do the numbers have same or different signs?
Different.
Different, which means your mind should be like, oh, I have to use the different sign rule, which is find the difference of the numbers and then keep the sign of the bigger number. So what's the difference between 32 and 16?
16 would be minus 16.
What's the sign of the bigger number?
Minus.
So guess what? It's negative 16. Boom, bash. That quick. 1, 2. Obviously, once you get the hang of memorizing your rules and whatnot, and distinguishing, was it when they have the same sign is when you add and then keep the same sign, or do you add and then pick the sign of the bigger number? You're going to be sort of confused at first, but just with a little practice in terms of a worksheet, you will pretty much get familiar with those rules. Let me throw another one up. Little pop quiz. Negative 22 plus negative 12. So, you're adding, right? Yeah, because it's an addition problem. So, do the numbers have the same sign or different signs? Same sign, which means you use the same sign rule. Everybody look at the cheat sheet where it says same sign. It says add and keep the sign, which means you add 22 plus 12, which becomes
34.
And then you keep the same sign that they both have in common, which happens to be negative. Is that pretty straightforward? Does anybody have a question on that? Because so far, those examples that I'm going over, so far we've only done 2 rules, which is when you're adding integers with the same sign, you add and keep the same sign. If you're adding integers with different signs, you find the difference of the number, but keep the sign of the bigger number. Those are 2 rules that you have to memorize. What happens if I throw this at us, though? Four minus a negative 4. We're going to stick with small numbers for now. 4 minus a negative 4. So in this specific case, we are going to be looking in this section here. Do you know why? Because, well, it says it right there, subtracting. We are subtracting this time around. There's a little minus sign in the middle of your 2 numbers. That means you are subtracting. So what is the one and one only rule for subtracting integers? Well, it doesn't really lay it out too nice, but this is the rule for subtracting integers, all right? Is everybody ready to write this down in their notes and memorize it? It's a fun one. It's one that everyone should remember. What is the rule for subtracting integers? It is keep, change, change. It says it right there, keep, change, change. Well, what does that mean? That means you literally rewrite this problem into an addition problem. But when you do that, you have to sort of change a couple stuff and keep a couple stuff. This first part, the first number, you're always going to keep it the way it is. 4, right? So that was keep, then you change. So you change your operation, and then you got to change the second number. So if we change the operation from a minus to its opposite, which is addition, you now have a plus sign. And then you change, again, the second number. What's the opposite of negative 4?
Positive 4.
Positive 4. Now, it doesn't make sense to put a plus 4 there. There's no such thing. If you didn't know this by now, positive numbers are just the numbers itself. So 4 minus a negative 4, in reality, is just telling you to do 4 plus 4. Why? Because we kept, and we changed, and then we changed. Keep, change, change. What's 4 plus 4? Test it out, my friends. On the calculator, you can literally do 4 minus negative 4, and it will give you 8. For some of you, this is not probably much, but for some of you, your minds have been blown away. 4 minus a negative 4. It's 8. How about we do a bigger number? Negative 25 minus a negative 17. So, negative 25 minus, this is a subtraction problem. Am I correct? So, it's a subtraction problem, which means, what's the one rule you must always remember about subtraction problems? Keep, change. So do that. Keep the same number, the same first number the way it is, negative 25. Change your operation from a minus sign to an addition sign. Change your second number from its negative to a positive. Now guess what? Now we're back to square one using one of the two of the adding integer rules. So ask yourself, do they have the same sign or different sign? Different, which means the rules tells us find the difference of the two numbers and then keep the sign of the bigger number. So what's the difference between 25 and 17?
8.
What is the sign of the bigger number?
Minus.
Negative 8. 25 is bigger than 17. What's the sign of the 25? Negative. So your final answer is negative 8. So yeah, the subtraction of integers, all it really is a conversion. Converting it into an addition problem, and then using, again, one of your two adding rules that you will come to know and love so much. Any questions so far? Because let's pretend you are going to come across this in the worksheet, but let's pretend we threw a couple problems afterwards. Don't know what happened. Such as that. How are you going to solve this by hand? Which again, for those of you taking GED, first 5 questions, don't be surprised that they throw this at us. Well, it's literally no different than the way we've been doing it. You would solve this the exact same way we did. You would almost sort of, in your mind or in a worksheet, just write that part out and sort of forget about the rest. And then you would solve this first, and whatever answer you get, you would bring everything else down afterwards. Negative 25 minus a negative 17. What is it that we got? I already forgot.
Minus 8.
Minus 8. So bring everything down. What are you going to do next? Well, you'll do the negative 8 plus 8. Negative 8 plus 8. So tell me. This is a weird one. Negative 8 plus 8. They're adding integers, which one of the rules am I going to use? Do they have same sign or different signs?
Different signs.
So, what is the difference between negative 8 negative 8 and 8? The difference is nothing. It's 0. What's the sign of the bigger number? Well, that's the beauty of 0. It doesn't have a positive or a negative. It's just 0. It's just 0. I mean, technically, it's positive, I guess, because it doesn't have a sign to the left, but it's 0. So bring down the rest of the other stuff, which in this case is the remaining minus negative 12, and then ask yourself what operation is in the middle. Is this adding integers or subtracting integers? What's the middle operation?
Subtraction.
Subtraction, which means you keep change. You keep this first number, you change its operation, and you change the second sign of the number. And now just have fun. What's 0 plus 12? 12 is the final answer. For some of you, all these rules seem tedious, or you probably have your own way of finding it. But if it's a little bit challenging right now, I almost guarantee you, within one worksheet, you will memorize these rules that could help you with problems like these, in which you don't really have a calculator to use on. So this is how you add or subtract multiple numbers with multiple different signs and multiple different everything. Any questions on this one? There is one keep change problem that I want to go over before we move on to multiplying and dividing integers. And that is a problem that looks like this. Negative 12 minus 4. So, is this a adding integers or subtracting of integers? It's subtracting. Again, always look at the middle operation to distinguish whether you're adding or subtracting, obviously. So, which means I have to keep change. So you keep the first one exactly the way it is, negative 12. You change your operation to an addition. But look at this 4. Is that 4 a positive or a negative? It's a positive because it doesn't have a sign to the left. So what do you do with that? Well, you do exactly what the rule tells us. You keep change. So we kept the first one, we changed the operation. Yes, my friends, you change that positive 4 into a negative 4. Watch out for that. Keep change. That means always keeping the first thing, changing the operation, and changing the second sign of your number. Now that you have made it into a addition problem, use one of those famous 2 rules. Do they have the same sign or different sign? Which means, do you add or find the difference of the numbers? You add the numbers. Because it says, if they have the same sign, you add the numbers. What's 12 plus 4?
16.
And then you keep the sign that they both have in common, which is the minus, which is negative 16. Okay. We're going to move on to multiplying and dividing of integers now. Now, I know what you're saying. How are we going to fit that into the lecture? How are we going to even have time to finish all this? Multiplying and dividing, that's the hardest thing imaginable. No, multiplying and dividing integers are actually pretty straightforward. Because these rules, at one point or another, you have heard of, and if you haven't, you learn it, and then it's easy to apply it to the math. Does anybody know the rules for multiplying and dividing integers? I'll give you the first one. A positive times a positive equals a what? A negative I'm saying times, but this rule is for both multiplying and dividing. So I should be saying a positive times and or divided by a positive equals a positive. A negative times and or divided by a negative equals a what? Positive. A positive times and or divided by a negative equals what? And a negative multiplied by a positive and or divided by a positive equals? Negative. That is the rule for multiplying and dividing integers. Well, what does all that mean? How do you apply that into the math? Really, really straightforward. Watch this. The trick with multiplying and dividing is forget about the signs. Just forget about them for just a brief second in your beautiful lives. Just ignore them. And just look at the numbers. What is 4 times 3?
Negative 12.
I just said 4 times 3. 4 times 3 is 12. Alright? So, just focus on the number first. Then ask yourself the whole rule. Alright? Then ask yourself, your first number, what was it? Well, it was a negative, right? Your second number, what was it? It was a positive. A negative times a positive, what is it? Well, it's right here. A negative times a positive gives me an answer of a negative, which means you just throw a little negative to your final answer. You do the multiplication or you do the division first. You get the answer always. That's priority number 1. You have no idea how many times I give this type of problem to a student in a quiz or in a worksheet. This is traditional, or not traditional, but a simple integer problem like this, negative 4 times 3. And they get the negative part correct, right? They get negative, but they accidentally, through a brain fart or through miscalculation on the calculator or whatever the case, they try to do it by hand. They just through brain fart moments, they put the wrong answer down. They do 4 times 3. What's the answer? Oh, 16. Okay, just a small little lapse of judgment. They get the wrong answer down. It's because they're all focused on this negative and positive and this and that, this and that. No, I tell the students, just for a brief minute, just get the answer first. What's 4 times 3? 12. Then go back and ask yourself, okay, the first number was a positive times a negative. Oh, the answer becomes a negative, right? So let's do another one. Oh, man. Negative 6 divided by negative 3. So negative 6 divided by negative 3. Again, focus on the number first. Always. What's 6 divided by 3? What is it? 2. Then ask yourself about the whole sign and its operation and its rules. It was a negative 6 divided by a negative 3. What's a negative divided by a negative? Positive, which means your final answer is 2. Again, no need to put a plus 2. It's just 2. What happens if I do put plus? Well, I'm not going to count it against you, but it should be a habit that you should rub off really quick. So, always do the math first. Do the division, do the multiplication, then go in and determine whether it's a positive or a negative based off of this rule. So, what is the rule for multiplying and dividing integers? It's all of this. Positive times a positive, negative times a negative, da-da-da, da-da-da. You're going to have to write all of that, by the way. Wink, wink, hint, hint on Thursday. So, I recommend you memorizing that.
Is it going to be a bonus question?
It will not be a bonus question. By the way, if you did not know, this is how I should have written it. This is how multiplication is going to look like from this point forward. Why? Because we are in pre-algebra, and the dot, I think you will see the dot from here and there with a couple worksheets left, but it'll soon disappear with more advanced algebra. But the x, the dots, all of that doesn't exist anymore for us. That means multiplication. 2 times negative 5. What's 2 times 5?
10.
A positive times a negative. What does my answer come out to be?
Negative 10.
So it's negative 10. You tack it on after. If you did not know already also, that means division. We no longer are going to see division like this or presented like this. This right here is how division is going to look like. Yes, fractions. Fractions, all it was pretty much division in a sense. But this is how it's going to be presented. Negative 8 divided by negative 4. So tell me, what's 8 divided by 4?
2.
A negative divided by and or multiplied by a negative is what? Positive, which means it's just positive 2. You see that little trick? Focus on the math first, then throw the negative or positive at the end. Always get the math done first. Alrighty. That, my friends, is everything related to integers. Any questions?